For example 3, we're just solving this formula for W, so we want to get the W all by itself here. So the 3 is attached to it through multiplication, and these things are just being added and subtracted. So my first step would be to undo the things, the D and the minus 1.5155p. So we have M on the left side, we're going to subtract D, and then we have a subtract 1.55 on the right side, so it becomes a plus 1.5155p, and that's going to equal the 3W. So we've subtracted or undone these things to get rid of them. At this point, I want to get the W by itself, so I'm going to divide both sides by 3. So we end up with W just being equal to M minus D plus 1.5155p, and all of that can be divided by 3. And that's fine, leaving it the way it is, okay, because that's now solved for W. Looking at example 4 here, we've got this funky equation, and we want to get W by itself. Now this one's going to require quite a bit of work because we've got a few things that are keeping the W from being alone, and I just see that we've got an A equals R equals, which is kind of funky. Let me go check my original here and see what's supposed to be there. Okay, and I do have a typo there. That was supposed to be an R takeaway here. That should just be a subtract sign, not a second equal sign. So I need to correct a couple things on this handout. So a slot's cut in the circular piece as shown. The piece has a radius R of 97.60 millimeters. The number of millimeters in the width is represented by W. Dimension A is 20.20 millimeters. Use the formula to solve for W. So we could take this whole equation and get W by itself first and then sub in our values, or we could sub in the values first and then solve for the W. I'm going to try solving this for W first just to show that, yep, it can be done. So let me rewrite that without all the stuff around it. So that's R minus the square root of R squared minus 0.2500 W squared. Okay, so all of this stuff under the square root symbol is kind of attached like being in a bracket. So my first step actually will be to undo the plus R. This is a plus R by subtracting R from both sides. So we're going to have an A take away R is equal to negative. So that's like having a -1 multiplying this square root symbol. Okay, and then I'm going to divide both sides by this -1 to undo that. Okay, and dividing these by -1, both of these by -1, the negative R divided by -1 will be positive R, and then the positive A divided by -1 would be a minus A. So I'm just simplifying that so that I don't have to work with a fraction there. And that's going to equal the square root of R squared minus 0.2500. I'm not sure why we have these extra 0's there. W squared. Now, the next thing I'm going to have to do is undo the square root symbol here. And the opposite of square rooting something is taking it to the exponent of 2. So I'm actually going to take this to the exponent of 2 on both sides. We're going to have an R take away A all to the exponent of 2. So in brackets. And remember, that does not mean square the first, square the last. It means square the first, double the product, square the last. But I'm actually just going to leave, actually, maybe I will square it out. At first thought I was going to just leave it, but the next thing I'm going to do is undo the R squared. It's a plus R squared. I'm going to subtract R squared from both sides. So we have our R minus A all to the exponent of 2. We're going to have a minus R squared. That's equal to negative 0.2500 W squared. All right. Now, I could leave this as it is, or I could expand and simplify. I think I will just leave it as it is. And I forgot to do what I was going to do, which is divide both sides by the negative 0.2500, which is multiplying that W squared. So we're undoing it by dividing it out. So then we have this being divided by negative 0.2500, and that's equal to W squared. And now to undo that square, I'm going to square root. And I think in this case, W is just a width, so we don't have to worry so much about the plus or minus piece to that square root. We really only want the positive square root because a width is just a positive amount. So our W will equal the square root of, and you want to make sure that square root is going to cover everything. So it's the r minus a all squared minus r squared. And this is also underneath the bracket. Now, you might also see this, that negative dividing, just the negative, dividing both pieces here. So you could potentially see this formula written as r squared minus, that's supposed to be a squared, minus r minus a all squared. So just turning that order around over that, and I believe 0.25 is a perfect square that we could actually square root. So you might even see that written another way. But I think that's pretty good. Now if I want to actually evaluate, so let me just put a little line here, our W is going to equal the square root of, that capital R is 97.60. We don't need the 0 there necessarily, squared, minus 97.6. Whoops. Wrong number. Let me see if I can erase that with this tool. There we go. That's better. So that's my r squared. To that, I want to subtract bracket, and then we want the r, 97.6. minus the a, which is 20.2. Close that bracket and square it, and that's all supposed to be over the 0.2500. And then it's just a matter of putting that in your calculator and evaluating it. And what I ended up with, and hopefully I put it in my calculator correctly when I did my draft version of this, I got 118.91 approximately. And that will be in millimeters, okay, because our other units are in millimeters.